Welcome. Let's try to solve another Leetcode problem. Maximum score words formed by letters. So let's first try to understand it. So we are giving a list of words. So this is a list of words. We are not sure if the words can be unique or not, but we are just giving a list of words. So the word's length is only 14, and the word's array's length is 14, but for each of the words, the length is only 15. Yeah, maybe we can solve it by using the brute force because of those kind of constraints. Yeah, let's just continue. And we are also having a letters array. So the letters are going to be lowercase English letters, and we are also having a score. Yeah, so the score, as we know from here, so for character A, so the score is 1. For character B, the score is 0. For this example, for character C, the score is 9. Yeah, so this is the score array. Yeah, so we are giving a lot of information, and let's just check the return. We are going to return the maximum score of any valid set of words formed by using the given letters. Yeah, so the words I cannot be used 2 or more times. So this means for each of the word, it can only be used 1 time. So we are giving an array like this, and for each of the word, we can only use 1 time. It means we're gonna take it and not take it for each of the time, for each of the word. So this is like a 0-1. Knapsack problems. Yeah, so if it is a 0-1 knapsack problems, so basically we're gonna use the idea of for each of the word we're gonna take it and not take it. We're gonna take it and not take it. Yeah, now let's just continue. For the first example, we are sure there can be some answers. So for example, dead and good, it meets the conditions and the score is 23. But there are also other conditions like dead and dog. So it is 21, but we're going to choose the maximum. And now let's just check the next one maybe. So for this one, the maximum is going to be 27. So we can choose like AX, BX, and CX. Yeah. And for this one, we can just choose the Leetcode. And we cannot choose the Leetcode because there's only 1 E. We need at least have 2 E's. And we need to at least have 3 E's. It means it is not possible, so we're going to return a 0. Yeah, I think we can solve this problem straightforward by using a knapsack 0-1 knapsack idea. And for this knapsack, I'm going to prepare a backtrack function, and inside I'm going to prepare an index I. I'm going to so the index I going to start in from the first word inside of the words array. And I'm going to prepare an answer because I want to put all the possible results inside my result array. Yeah, so first of all, I want to put all the possible results like this kind of a result, then and good, put it inside the result array, and then I'm going to use a brute force to check what could be the maximum score. So I'm going to check this I. If I equal to n, definitely I've checked all of the words. So I want to put it inside of the gonna append the answer, and I gonna have a return. Now I have 2 ideas. I can take it and not take it according to the 0-1 knapsack. So for the dog, I can take it and not take it. So if I take it, so the backtrack is gonna be I plus 1 with an answer. I don't need to do anything. Now I want to take this dog, but before I take it, I need to check if I can take it or not. But how can I check that? I think I need to prepare a counter. I need to count all the letters inside of counter. For this C is my counter. I want to count all the letters. Now let me just use this kind of idea. If I were to take this letter, this means I need to check if this C must be more than and equal to the counter of the words I. If it is more than and equal, definitely I can count it. I can use the backtrack function. So I plus 1, and the answer gonna plus the array, and inside it's gonna be words I. Yeah. Now let me just maybe return a 0 or some number, and because I want to check what could be inside the result. Now let's just check what is inside the result array. There's nothing inside the result array. But I think this is Yeah, I think this is a this should be okay. Yeah, I think I need to finish all the functions before I check it. So, if this is say if the counter is more than and equal to the counter of words I for the current word. So basically, I need to check if I can use this backtrack function or not. Yeah, but before that, I need to just need to check the counter, because for the counter I need to remove the letters. So for example, this is a capital C. Let me just use the for letter inside the word I. Yeah, so if it meets the condition, so C letter gonna minus equal to 1, and after the backtrack function I need to recover it. So for letter in word I, so C letter gonna plus equal to 1. I think that's gonna be the entire backtracking function, and after that I will to check if I can get a result array or something. Now it is still nothing. Let me check. Yeah, I think because I forget to call the backtracking function, I need to call it. So otherwise, how can I get the result? So it's gonna be from the index 0 to an empty array. Yeah, now let me just check what could be inside the result. And I didn't prepare this n, so the n gonna be the length of the words. Yeah. Now let's just check what is inside. As we can see, it can be an empty array, it can be good, bad, or some combinations. Yeah. Now we get this kind of array. What we're gonna do is that we just need to check the subarray. So inside of the subarray, we just need to check the score, and finally we just need to return the maximum score. It may be bad and good. Yeah. Now let's just use this idea to get the final result. I think from here everything should be okay. Yeah. Since I'm going to use to get the score, I'm gonna prepare a score dictionary. So inside it's gonna be a zip. Yeah, because for the dictionary, if I put two values, then basically I can prepare a key-value pair. So I can use a zip with ASCII2 lowercase, because in Python we can directly use it, and we can use the score. Yeah. Now we have a score array. Let me just print out what is. We have a score dictionary. Let's just print out what could be the score. So for the first example, this is my score dictionary. Yeah, as you can see in Python, everything could be just so concise. We don't need to write so many code to prepare a score dictionary. We just use the score equals to the zip of all the lowercase letters with the score. Now I think we are safe to get the final result. So I'm going to prepare an answer, and I'm going to return this answer. I want to check all the array. So for array inside the result, I'm gonna check the answer. It's gonna be the maximum of the answer. I'm gonna use another function. Maybe I'm gonna use the get score. So the get score inside is gonna be an array. So finally, I'm gonna return the answer. Yeah. Now I just need to finish this get score function. Let me put it here, maybe. So I'm gonna use a get score function. Inside it's gonna be an array. Here I'm gonna prepare. Maybe I'm gonna use a score equal to 0, and for each word inside the array, so the score gonna plus equal to sum of yeah. So where is my dictionary? I cannot use the score because here I used a global variable score. Maybe I just use a result. So the result gonna plus equal to sum of the score C, a character. So for C in word, finally I just need to return the result. So I think everything from here and here is gonna be just so easy. We don't need to understand much, and basically we need to understand this gonna be 0-1 knapsack problems. Yeah. So for each of the time, we will not take it. If we were to take it, we have to check it. If we were to check it, we have to recover it. So from here, yeah, we just reduce the character, and for here we just recover the character. So here -1 and here +1. I think you should be familiar with this kind of tricks to solve the backtracking problem. Yeah, now I think everything should be okay. I just need to run it to check. As you can see, it works. Now let me just submit it to check if it can pass all testing cases. As you can see, it passed all testing cases and it's pretty fast. Now let's analyze a little bit about the time complexity. So the time complexity will focus on this backtracking function. So for each of the backtracking functions, basically we need to check how many words inside of the words array. I think it's gonna be something like 15 or 14, I forget, times 2 to the power of 15. Yeah. So this is gonna be the time complexity for the yeah, let me check for the backtracking. Yeah. So it is 15 times 2 to the power of 15. Yeah, but inside, I think there is also some comparisons with this counter, with the counter of words. Yeah, and there's also a for loop. So for each letter inside of the words. So for here, we just need to have another, maybe we need to, so how many letters inside of the words. I think yeah, it's gonna be another 15. So it's gonna be 15 squared times 2 to the power of 15. So 15 squared, like and I forget, 15 times 15. 15 times 15, it's gonna be 200, maybe 25. I forget what is 15 times 15. I think it's 225. Yeah, so this is 75. It's 15. It's 225 times 2 to the power of 15. So 2 to the power of 15. So 2 to the power of 10 is like 1000. So 2 to the power of 5, it's gonna be like 32. 3 times 10 to the power of 4. So finally, it's gonna be like 6 times 10 to the power of 6. So this is why we can pass it, because in Python, if it is less than 10 to the power of 7 or 8, normally we can pass it. Yeah. So I think that's it for this problem. Basically, we just need to know how to use the backtrack, the basic backtrack, and how to use the 0, 1 knapsack. Yeah. Thank you for watching. See you next time.